Hello, everybody. We're going to be talking more about functions today. And in our discussion about functions, I'm interested in a couple of major ideas. That's what's going to be discussed here. And the first idea is that we should think about questions before we just dive right into writing our responses. So you think first, you plan what you're going to do, then you act it out and write it down. Another major idea is to how to communicate using function notation and how to prove you understand function notation by translation into English. So to demonstrate, I have a couple of functions here. And in the first case, I'm given a graph. It shows profits for a theater. It seems like I sell tickets, and however many tickets I sell is going to determine how much profit I make. So profit is a function of tickets sold. Now you notice I studied the graph before I even went to the question. I don't know what the first question is asking yet, but I'm just trying to figure out what the graph is trying to tell me. Finally, when I do get to the question, it says how many tickets need to be sold in order to show a $200 profit. I put a little note here that I'm asking to solve f of x equals 200. Solve meaning find the variable, in this case it's x, that allows profits to be $200. So to understand the question, the first thing I do is I move in and look at what I know. Since I was given profit, I look over on the graph to find the profit axis, and I find the profit is $200. So I find $200, I follow it over to the graph, I follow it straight down, and I make an estimate. Now this is not a perfect graph, and I don't know the exact value, but it appears to me more than 70, less than 80, so around 74 ticket sales will give me a profit of $200. That's an approximation, but it's good enough based on all the information. So now I actually have the answer. I thought about the question, I thought about the answer to the question, now I have to write it. First thing, if f of x is 200, then x is approximately 74 tickets. So I put in a label whenever I can, but I ask the question in math language, and I answer the question in math language. So we say if f of x is equal to 200, it means that the value of x should be around 74. Now, translation into English, don't say x and y, talk about tickets and profit. So to earn $200 profit, they need to sell about 74 tickets. Done. If you'll notice what happened, I spent some time first understanding the question. Then I answer the question using math notation, and finally I answer the question in English. In terms of what evidence is put down, you can mark up the graphs and you can mark up the problem to point out certain things that you're looking at or focusing on. This demonstrates that you're thinking about the question first, then you're showing me that you know how to skillfully use the notation of mathematics to answer the question in the most efficient way, and then you prove to me that you understand the nature of this language by sharing with me what this language says in the native language, English. Carrying on then, we look at the second problem. The second problem dealing with what's the profit if you sell 35 tickets. So the question is asking me what is profit. That means I need to know the dependent value. 35 tickets were sold. That's something I know, and that's on the independent. So I find 35 on the x-axis, follow it down to the graph, and I make my best estimate. It's clearly not negative 100, so I'll estimate a value. I estimated in this case negative 90, and it's just an estimate. If you had negative 85 or negative 95 or anything in this ballpark, you're fine, as long as you can provide evidence on the graph how you got your answer. So that's the thinking, understanding the question, trying to get the answer. Now I need to write it out. First of all, I say f of 35 equals approximately, there's a squiggle equals, it's approximately, negative $90. We don't usually say negative $90. What we say is a loss. So my translation into English is if 35 tickets are sold, the theater would lose about $90. Notice this is positive because I said the word lose, where this says lose $90 in math language much more efficiently. Just prove to me that you know. So once again, just go back to an earlier thing. We understand the question, mark out what we're thinking, then we answer using math notation and answer in English. So we have the exact same format here. Next question is interesting because what it says is, according to the graph, what is the cost of running the theater? Now at first I'm a little confused because here we have tickets, that's one variable, and here we have profits, that's another variable. It doesn't say anything about costs. So in order to do this, I have to think a little further, and I think about profit and what profit is. And profit is the amount of money that the theater gets to keep after they've covered their cost. So you can see why profit is negative in the first place. One of the reasons why profit is negative is if you sell, for example, 35 tickets, you don't quite cover your cost. You still owe $90, which means if I look at the graph and find what's called the y-intercept, this is the amount of money that would be lost with 0 tickets sold. In other words, that's the cost. If I sold 0 tickets, I would still owe about this much money, which means that's the amount of money that it takes to run the theater. I need to sell over 40 tickets in order to be able to cover those costs. So how much is the cost? Well, first of all, in math notation, I estimated around negative 360. So P of 0 is about negative 360. Translation to English, costs around $360 to run the theater. I have enough evidence to support this because I have the circle on the graph, understanding what cost is. So here's my comprehension piece, here's my notation piece, and here's more about communication and comprehension of what I just said. Finally, the last question, also rather challenging because it's not obvious immediately, but it says using information from the graph, determine the approximate price of one ticket. That's really hard to do because on this scale I can't go over 1 and then find out how much the graph increased by. But I do have a lot of information based on my prior answers. One of them is this. When I sold 35 tickets, my profit went up from negative 360 up to negative 90, which means it was an increase of $270. So I can actually write, after 35 ticket sales are sold, $270 were added to profits. I can form a ratio. The $270 for every 35 tickets means there's $54 for every 7 tickets, or 7 5 cents dollars per ticket. Translation, tickets cost just over $7.50. Now, it's not a perfect answer, but what I could do is back it up. If I had the space here, I could show that there's approximately 46 tickets to go from negative 360 up to 0. So if I did 360 divided by 46, that would give me another ratio. It will be near 750, but not exactly the same. I could also show the increase from 35 to 74, which is about 39 tickets, and then there was an increase of $290, so I could do 290 divided by 39, and I would end up with a result again similar to $750. These are just estimates, which is why I underlined the word the approximate price of one ticket. Careful the word, pay attention to word choice, because if I say approximate, then you don't have to obsess over the details. Just show me your best possible result from the information given. In this case, dealing with bouncy balls, the first question, I'm going to graze over the first two and just point out that I'm doing the same thing. I think about the question and I mark off what I'm thinking about. I answer the question in math language, and then I answer the question in English. Second question, understand what's happening. I'm given the 4 bounces. That means I had an 80 centimeter rebound. I answer it in math. I translate into English. So that's how I would simply write that up. This is not the challenging part of this exercise. The challenging part is asking, what height would you expect for 3 rebounds? And the issue most people would do here is they would go halfway between 140 and 180. But if we recognize that we lose more from bounce 2 to 3 than we would from bounce 3 to 4, based on the data trend, we lose a whole bunch of rebound height from 0 to 2. We lose very little rebound height from 6 to 8. Therefore, it's safe to say that we're going to lose more on the bounce to bounce 3 than we would on the bounce to bounce 4. Now, that's a lot of stuff to explain, and I don't want to have to write all that out, so what I am going to do is I'm going to make a graph. Now, you can see here I use technology to make my graph. That's a time issue. I'd like to go home and play some Super Smash with my son. So I made this graph on technology. You would use a ruler and a pencil to make this graph. So we're going to use a ruler to make the X and Y axis. We're going to use a ruler to measure out our scale, and we'd have to scale out the x-axis to at least include 8 bounces, probably a little more. Furthermore, I need to make the y scale so that I can get at least 250 centimeters on it. So I make the necessary adjustments, and then I plot the data. Getting these points on the grid would also, I would also use a ruler to make sure that once you found, for example, where 6 bounces is, you follow up to the graph, and you want to make sure that you're plotting that as close to accurate as possible. Because once the graph is made, a more accurate graph will give you a better result of the estimate of the rebound height. I accept on this any answer less than 110 centimeters because of that halfway issue. But once again, how did I get the answer? Write the answer in math language, translate it into English. I hope this clears things up. I want you to realize that this is not mathematically challenging as much as it is communication challenging. So again, we have a little bit of how to read the mathematics, how to write our answer in mathematics, and how to translate in English. If you keep those things in mind on the next assessment, you're going to be fine. Thanks for listening. Have a great day.